So we've seen that at the ordinal level of measurement, the values do have a natural order. We can tell which one is bigger, but we cannot measure them exactly and objectively through some kind of instrument. At the next level, however, we can, and this is the interval level. So at the interval level, a variable has values that are obtained through an objective measurement, and therefore they're accurate. They're not subjective impressions, but are on a scale where ratios of values do not necessarily represent ratios of size. Now this may be looking a little bit confusing, so I'm going to give you a couple of examples just to show you what we mean, and also just to make you relax a little bit. Let me tell you that this level of measurement is very rarely occurring in statistics, and in the most, even in the case of when it is used, it is analyzed pretty much like the next level, which is the ratio level. Okay, so you still need to distinguish between the two in some extreme situations, and just to show how good you are at these things, but it's not going to be a big deal. So let me give you the two cases, which are really the two major applications that you will find. The first one has to do with temperatures. Of course, as a nurse, the temperature of a patient and in another number of situations can be quite important. Well, if you think about temperatures, they're measured on a scale, right? So let's look at these two thermometers. One of them has a temperature of 20 degrees. The other one has a temperature of 60 degrees. As numbers, 60 is 3 times as big as 20, so the ratio of the two is 1 is 3 times as big as the other. But we can't really say that one temperature is 3 times as big as the other, right? So look at these two and look at the other one. What would be the ratio of 20 to negative 20? Minus 1? So that's the opposite temperature. In what sense? Does it really make sense to talk about it in this way? Also, 60 over negative 20, minus 3, what would that mean? It doesn't even have a special meaning. Okay, so even though temperatures are measured accurately, their ratios do not represent ratios of size, and that's because the number 0 is somewhat arbitrary. 0 usually in the Celsius scale means when the water freezes. Okay, that's a nice way when we're measuring temperatures. Is a nice point of reference, but in terms of ratio doesn't do anything. We could have chosen as 0 something else, as if in fact happens with the Fahrenheit scale. Okay. The other situation where interval measurements occur is when you have scores on large questionnaires. So sometimes you have a questionnaire where each question is really one of those Likert scale kind of question on a scale of 1 to 5 and so on and so on. And then you add up all the scores that you get on each of the questions, you come up with a big final score. That number can be thought of as have been obtained in some kind of objective way. Sure enough, each one of the questions is not that objective, so we'll look at that more in detail in class, but the total score can be thought of as having been obtained objectively. However, these scores, again, their ratio sometimes doesn't really tell us very much. Too fast. So again, we have to be careful, but these are the only two cases where this level will occur, and as I said, in both cases pretty much we can use the same methods as we can use on the next level. What is the next level? That's the ratio level of measurement. As you can imagine, at the ratio level we have objective measurements on a scale where ratios actually represent ratios of size. Okay, so when we're saying that one measurement is twice as much as the other one, we mean that the quantity is twice as big. Again, let me give you just a few examples. We'll do lots more in class. But pretty much any physical quantity. Okay, so let me say again. Actually, I'm cheating you a little bit. I said let me give you some examples. That's not really an example. We'll see lots of examples in class. But age, weight, height, all these kind of things and more. Anything that can be measured on a scale which in fact measures a quantity is at the ratio level. Of course, you can understand that this is something which occurs very frequently, and therefore you want to get used to it. Okay. The important thing that you want to do is make sure that you're not going to confuse a ratio variable with an ordinal variable. This is something that sometimes is often done. An ordinal variable is assumed to be at the ratio level and analyzed as if it were, while in fact it is not. So again, I know at this point we have gone through all 5 of them. There may be a bit of confusion. We will clear it up through examples in class.